I know that I've mentioned the STP timers a lot in this section and we haven't gotten to exactly what they are, so we're going to do that right now. And I'm going to show you a couple of very important notes about these timers. And first off, once our root bridge election is done, we know the root bridge is the only one that actually originates the BPDUs. That's a hello BPDU and it gets sent out every 2 seconds. So if there is a problem, it gets detected pretty quickly because that is by far the fastest of all our protocol, keep alives, frame relay, OSPF, EIGRP, none of those guys send hellos every 2 seconds. But STP does, and as long as the non-root bridges are getting that, and whether they're getting it directly from the root or they're getting a forwarded copy every 2 seconds, they know the path to the root is unchanged and it's stable. Now once that heartbeat disappears, just like with the human body, that's not a good thing. And with STP, it's an indication of a failure somewhere along that path. A port's gone down, somebody pulled out a cable, the whole switch has gone down, could be anything. And what will happen is that STP then runs the STA again to determine the now best available path, and ports are brought out of blocking mode as needed to build that path. We know that's not immediate, and here at last are those timers. The hello BPDUs carry values actually for 3 timers. The first one is the hello time. That's the time between the hello BPDUs. The default is 2 seconds. Max age, the bridge should wait this long after not hearing a BPDU before running the STP algorithm. So we're waiting 20 seconds to actually start doing something about that missing BPDU, about the missing heartbeat. And that may seem like a long time. You might want to change that. We'll get to that in a minute. But the reason we have that is that if you have a flapping root port, let's say the cable's gone bad, there's a little short in the hardware, whatever's causing it, and a flapping link is going up, down, up, down, up, down. If you've got a port doing that and it's the root and STP sees it go down and say, okay, now I got to come up with another one. I got to come up with another root port. If that happened immediately, you would have that interval where the flapping port was then going to be up for a moment and that new root port would be up. And that's just the opening that a switching loop needs to get started. So that is why we actually have that max age delay. Now forward delay, we actually have 2 of these because this is the length of time of both the listening and learning stage. So we've got a 15-second delay for each one. Listening state, 15 seconds. Learning state, 15 seconds. So we've got a 50-second delay there, plus a little bit of time for to detect the missing BPDU in the first place. It's almost a minute. And you're just thinking, oh, that's a long time, man. I want to change those timers or disable them or do something. Well, Cisco's kind of ahead of you on that, but for good reason, because these timer values were not pulled out of the sky or anywhere else. They didn't just make them up. They're set at these values to prevent switching loops during those recalculations and transitions to new root ports and new designated ports, etc., while STP converges. You really want to change these at your peril. I'm not saying it's always evil to do so, but I'm saying it's generally a good idea to leave them where they are. Now here's a bit of a gotcha. To change these timers, you have to do so on the root. You can change them on a non-root switch, and the switch usually, the iOS is usually very helpful. Oh, well, Chris, what you meant to do was this, or did you know you'll have to reload this to take effect? You're not getting anything from the switch on this one, baby, because it's just going to say, oh, okay, you're changing the timers. But if you do it on a non-root, as you're going to see in a second, the changes only occur to the bridge ID field, and those aren't the ones that count. So let's take a look at what the heck I'm talking about here. Let's go ahead and bring the live equipment up. And I will run show spanning VLAN 30, good as any. And you can see that we have hello time, max age, and forward delay under both root ID and bridge ID. So we're on the root right now. Let's go to a non-root switch and look at these timers. And it's spanning VLAN, then whatever VLAN you want to change the timer for, because this is, of course, these are different instances of STP. And you can see the 3 right here. We saw these in a couple of labs. Forward time, hello time, and max age. Here's where you change them. And if you wanted to change forward time, let's say you just wanted to disable that. It's like, hey, I just want to go straight from blocking to forwarding, and that's it. To heck with the forward time. I don't want that. Well, you can't change that to 0 actually. Check this out. The lowest you can set it to is 4 seconds. And it's interesting to note that you cannot set this to 0, which would effectively disable it. So you're thinking to yourself, okay, I'll just set that max age to 0. Well, you're not going to set the max age to 0 either, because that is 6 to 40 seconds. You can't set it below 6. And hello time, let's check out the interval on that. You can set that down to 1, but that's really it. So you can't set any of these values to 0. So let's go back up to forward time, and you say, okay, I'm going to knock it down as far as I possibly can, and I'm going to set that to 4 seconds. And believe it or not, there are no options there, and we just run show spanning. Let's do show spanning VLAN 10. And you can see that the forward delay changed here under bridge ID. Well, that's fine if this switch one day becomes the root, then it will go up here. But if it's down here, it's not taking effect for anybody. You just changed it locally. So if you want to change it and keep it consistent, because if you're changing it, you need to keep it consistent throughout the VLAN. You don't want to just change it in one little place. Then you would need to change it on the root. So, the timers are really straightforward. Nothing real complex here. Just make sure that you don't try to change them to 0 because you can't. And then, of course, if you're going to change the timers, you can do so only on the root. So that's some material here. Yeah, let's talk about those states a little bit longer here. Let's hit it right here while we're talking about those states, especially listening and learning. Because we know that transition is not instantaneous. We have listening and learning, and we have it for a reason. A port coming out of blocking, it goes into listening, and the port is listening for hello BPDUs from other possible root switches. And that's where the spring cleaning comes in too. I know I mentioned that in another video. I do mention some of this twice because it's very important information. And if a MAC entry isn't heard from in that time frame, it's going to be tossed out of the table. We're getting rid of stale entries basically. And again, that's the forward delay timer. Then during the learning state, we're putting fresh baked entries into the MAC table, so to speak, because the switch is learning the new location of switches and ports as the frames come in. Ports in learning state do not forward frames, though. We're still not doing that. And just to go over the timers here one more time, the switch is going to wait 20 seconds without a hello before beginning the transition process. Then the port comes out of blocking, goes into listening for 15 seconds. Port transitions from listening to learning, stays in learning for 15 seconds. And then finally it goes from learning to forwarding. I mentioned disabled as well. Some non-Cisco documentation I've seen over the years doesn't even consider this to be an official STP state, but we are on Cisco's field here, so to speak, so we certainly should. Ports in disabled mode aren't doing anything. They're not learning MAC addresses, they're not accepting or sending BPDUs, they're just sitting there disabled. Now, we always have a little bit of an exception with networking. And with these timers, there's no exception here. That exception for us is PortFast. Now, consider how long it takes this entire process. You're looking at almost a minute because you got your 20-second max age delay, you got your 15-second forwarding delay, and then you have another 15-second forwarding delay. Well, in certain circumstances, we can avoid these delays with PortFast. Now, PortFast allows a port to skip listening and learning, and you're thinking, all right, fantastic. Now we're getting somewhere. We can't disable them. We'll just skip them. Well, it's fine as long as you're using it in the appropriate place. And the appropriate place is a port that connects to an end user device. You don't want to use it on a port that leads to another networking device, such as, say, another switch. And we'll look at this on the board. Actually, I've already got it right here. You get the world's longest Cisco warning, I think. This is just putting spanning PortFast, and you get this huge message, warning. PortFast should only be enabled on ports concentrated to a single host. So it's telling us we can't say we weren't warned. Connecting hubs, concentrators, switches, bridges, etc. I love the etc. It's like in anything else you come up with. To this interface, when PortFast is enabled, can cause temporary bridging loops, which is like getting punched right between the eyes temporarily. It's still going to hurt. Use with caution, and note that caution is in uppercase, so you know they're serious. And that's going to tell you PortFast has been configured, but it'll only have effect when the interface is in a non-trunking mode. In certain circumstances, connected with a PC, it's great, but you don't want to run it between two switches. There is an excellent real-world application for this, though. I've used this many times, and you might want to try this out one day. What can happen is those built-in delays, it can mess with DHCP, and it can mess around with your PC getting its address in a timely fashion or getting it at all. And if you're having trouble with that, I would recommend giving PortFast a try on the port. Just make sure it's on the port leading to the PC. And then when the port opens and it transitions quickly to forwarding, DHCP should work just fine. And you shouldn't have any danger of switching loops if you have a PC on the other end of the link. That is it for the timers. We're going to go into a couple of fantastic features, probably my two favorite ones in this entire part of the course. Per VLAN load balancing and ether channels. And we're going to do the per VLAN load balancing first, including a lab that I've never done in a course, so I know you're going to enjoy that. So I've noticed some sources are just talking about per VLAN load balancing, but I want you to see it. So we're going to configure it on the live equipment, and then we will hammer ether channels. So take a breather, and I'll see you on the next video.